Hello, math lovers. Welcome back to the Math Culture channel. Today, we'll be discussing an important topic called the algebraic properties. Today, we'll be learning three different properties, and they are the commutative property for addition and multiplication, associative property for the same, and distributive property. Again, the knowledge of these algebraic properties are so important because they help us to simplify complicated algebraic expression. And so, a solid understanding of these three properties will make algebraic problems easier for you to tackle in the future. The first of them is the cumulative property, the second is the associative, and the third is the distributive. To understand the commutative property, let's first of all talk about the mathematical expression that represents it. It says that irrespective of the order in which you are adding two things, the answer will always be the same. Okay, so whether you say x plus y or y plus x, the answer will always be the same. In other words, the order doesn't matter. So x plus y would be equal to y plus x. So let's add these two numbers. 2 plus 7 will always be equal to 7 plus 2, whether you write the 2 first or you write the 7 first. So 2 plus 7 is 9 and 7 plus 2 is 9. So an easy way for you to grasp this concept is when you think about when you are packing your lunch, when you're preparing to go to school. In your lunch box or for lunch, you're expecting to have apple, sandwich, and juice box, right? So whether you put the apple first or the juice box first, it doesn't really matter. In the first scenario here, we're saying that we're putting the apple first into our lunch box, followed by the juice box and then the sandwich. In this other scenario, we say put the juice box first, followed by the sandwich and the apple. It doesn't really matter. The most important thing is that at lunch, all three will be in the box, right? So this same principle applies to multiplication. In other words, if you multiply a by b, you get the exact same answer when you multiply b by a. So to use some numbers to express this, we say 6 times 4 is always equal to 4 times 6. The order does not matter. Here you get 24. Here you also get 24 as the result. So always remember, for the commutative property of addition, the order doesn't matter. Next property would be the associative property. The mathematical expression for this is x plus y plus z is always equal to x plus y plus z. So what we have just done is for the expression on the left term, we have only regrouped it to write or for it to become the expression on the right side. In other words, we grouped x plus y here, and then we now group y plus x here. So the associative property implies that regrouping does not change the outcome. So let's use some numbers so that it can be easy for us to understand. Let's say we're adding 1 and 2 and 3. We're saying that associative property means when you say 1 plus 2 plus 3, you will get the same outcome as when you say 1 plus 2 plus 3. So looking at both sides, this will be 3 plus 3, which results in 6. And here we'll be saying 1 plus 5, which also results in 6. In other words, the associative property is the same for addition and multiplication, irrespective of whether you regroup it or not. Now, for us to understand this better, let's take an everyday example. Let's say, for example, in your backpack, right? You have your backpack has two compartments, and each of these compartments can take 2 books. However, when you were preparing for school, you had only 3 books that you wanted to take to school, right? So in the first compartment, you put books A and B, and in the second compartment, you put book C. This is the first group, or this is the first method by which you could have done it. The other method is that in the first compartment, you put book A and book C in one compartment, and in the other compartment you put book B. So irrespective of how you arranged it, whether it is method 1 or method 2, one thing is sure, the weight of the backpack will remain the same. And that's what the associative property is telling us, that irrespective of how you group the books, the outcome, which is the weight of the backpack, will always be the same. So this principle, or this associative property, applies to multiplication as well. So let's assume I want to multiply 2 by 3 by 10. In the first scenario, I decided to multiply 2 by 3 first and then multiply by 10. Or I decide to multiply 3 by 10 first and then multiply the result by 10. The regrouping doesn't change the outcome. That means this would be 2 times 3, 6 times 10. That results in 60. 2 times 3 times 10, that is 2 times 30. This equally results in 60. So regrouping does not change the outcome. 60 here, also 60 here. Let's talk about the third property, which is distributive property. In this property, the mathematical expression is A into B plus C. What we're saying here is that for us to simplify this expression, how we go about it is to distribute A on B and then again distribute A on C. To break this down, we say A on B, A times B plus A times C. It means we're sharing A across B and C. So let's take a real life example again. Let's look at the box of orange scenario. Let's assume you have a box of orange, a box that has 3 oranges. Okay, the box has 3 oranges and there are 3 other similar boxes with the exact same number of oranges. There are 2 ways by which we can divide this amongst 2 friends, say for example Matthew and Michael. So let's assume again Matthew and Michael are my friends. There are 2 ways by which I can divide this box of oranges by them, among them, or among them. Yes, so the first method will be to give each of those friends the oranges box by box. In other words, I want to give one box of 3 oranges to Matthew. In this case, this is Matthew, right? And the other 2 boxes of oranges I'm giving to Michael, right? So in each case, each of them will receive 6, which is 2 times 3, 6, 2 times 3, 6. The other way by which I can go about giving them the oranges is that I can decide to distribute the oranges individually to them, or share the oranges across both of them. In other words, I can say Matthew first. I can say Matthew, take 1 orange, another orange, another orange, right? And then I would say Michael, take 1 orange, another orange, another orange, and then I repeat the process again so that it can occur 2 times, right? So I would say Michael, take another orange, take another orange, take another orange. Matthew, take another orange, take another orange, take another orange. So at the end of the day, In the first scenario, Matthew is getting 6 oranges in total. Michael is getting 6 oranges in total. In the second scenario, they get the exact same total number of oranges, which is also 6. I hope that helps you to understand the distributive property. So let us put a number to this mathematical expression, right? So here we're saying that 2 into 5 plus 6. So what we're saying here is that we want to distribute 2 over 5, and then again the same 2 we're distributing over 6. So this becomes 2 times 5 plus 2 times 6. So to simplify this further, we should have 2 times 5 plus 2 times 6. So that will be 10 plus 12. And if you want to do this even further, that would be 22. I hope this helps you understand. So exceptions to this rule are definitely subtraction and division. Subtraction and division are not commutative. Again, subtraction and division are not commutative. So what we are saying there is that if we want to subtract 6 from 10, it is not the same. This sign means not equal to, as changing the order and saying 10 minus 6. 6 minus 10 will give you minus 4. And that is not equal to 4. The same thing applies to division. You could say 20 divided by 2 is not equal to 2 divided by 20. 20 divided by 2 is 10. And that is not equal to 2 divided by 20. In this case, if you want to break this down a little further, it will be 1 over 10. And for sure, guys, 10 is not the same thing as 1 over 10. That's what we mean when we say division is not commutative. So in the same vein, subtraction and division are not associative. So putting numbers to that, what we're trying to say here is that 3 minus 5 minus, say, 1 is not equal to 3, excuse me, we're saying 3 minus 5 minus 1 is not equal to 3 minus 5 minus 1. That's if we regroup this way. And that's because when we have brackets, we must evaluate the numbers in the bracket first. So for this one, 3 minus 5 is minus 2 minus 1, right? Minus 2 minus 1 is minus 3. Let's come to the other side. We say 3 minus 5 minus 1. Because 5 minus 1 is in the bracket, we have to evaluate it first, right? So 5 minus 1 is 4. So 3 minus 4 is minus 1. So what we're saying here is that the left hand side is not equal to the right hand side. And definitely minus 3 is not equal to minus 1. That's what we meant when we said the subtraction is not associative. We also said division is not associative. So what that means is 10 divided by 2 divided by 5 is not equal to 10 divided by 2 divided by 5. So if we simplify the left hand side, we have 5 divided by 5, which results in 1. And for the other side, we say 10 divided by 2 over 5, right? So this becomes 10 times 5 over 2 which becomes 25. So the left hand side is 1 and the other side is 25. Definitely they are not the same. That's all I have for you for today, math lovers. Thank you for joining us again today. If you found this content useful, please share to your friends. Do not forget to subscribe, and thank you.